Alright. Write down phi x, phi y, sx, sy in each of the examples below in terms of time t. Alright. First of all, draw yourself a picture. You're going to need a diagram. Please, in an exam, don't do a tiny diagram. You're going to be given a full answer booklet, alright? So I don't want somebody doing something like this where I'm trying to figure out what the angles are. See, like it's awful, right? So when you're doing your diagram, I want it as large as you can happily fit it in. Examiner will like it. It's easy to understand. It's a good idea. So we go reasonably large. Okay, plenty of space to fit in anything we need. Now, comes up here. You throw it at this angle. Now, for those who aren't in the other day, is that we redefine what the x and y axes are. Okay, the x-axis is always parallel to the wedge, or parallel to the plane, and the y-axis is always perpendicular to that plane. Okay, so your phi x, phi y, sx, sy, now they're no longer parallel with gravity, and they're no longer perpendicular to gravity. You get what I'm saying? Because gravity acts straight down. This means gravity will take place in both the x direction and the y direction. Okay, so gravity has an effect. Alright, next thing. We do angle alpha, and then we do angle beta. We start off with what we always do. The thrown angle alpha, and you end up with u cos alpha, u sine alpha. Everybody cool with that? Alright, next thing is you're going to have to break up your, what we call our gravity triangle. So I'll do the gravity triangle in red here. Gravity acts straight down. And make this triangle reasonably large if you want. To draw this triangle correctly, you need to draw perpendicular to the plane. So you draw perpendicular to the plane, and you stop when you can draw the other side parallel. So this line here is parallel to the blue one. Okay? Draw it that way, make sure you do it that way. Now, for those of you that don't remember, this here is 90 degrees, which will make this angle here, anybody? 90 minus b. Why is it 90 minus b? Angle 1, angle 2, and angle 3 all have to add up to 180. Now, then angle 1 plus angle 2 here, what's the two of them have to add up to? 90. This makes angle 2 beta. And for those of you, you can prove it to yourself. If you forget, that's how you prove it. But most of you will just learn off by heart that it's always the same as the angle of. Yeah. Right. Can everybody? Now, nextly, gravity. G cos B and sine B. Alright. Now we're going to do our phi x, phi y, sx, sy, right? Alright, start off with Phelan. Phelan, phi x for me, please. Cos alpha minus. Now, phi x is in this direction here. And we can see that this part of gravity is going against it. So what does that mean? Minus gt sine b. Okay? You do the next one for phi y. Yeah. Yeah, u sin alpha is going straight up, and g cos b is going straight down. So that's why it's negative, so minus gt cos b. Everybody cool with that? If you do it correctly, they're the opposite trigonometric function. Cos's turns into sines, sines turns into cos's. What's the danger of doing it the shortcut way, where you just change them around? Can anybody tell me? If you get the first one wrong, you get them all wrong. Okay? It's faster, but it's costly. Wouldn't do it in an exam. Next one. What about Sx? Sx? Yeah. Half. Yeah. Yeah, good man. Finally, the last one. Yeah. Yep. Awesome. And you're done. That's all you have to do. They just want you to be able to make all the equations. Keep going. All right. Today we do the gravity triangle. This one, the gravity triangle is in oh yeah, it's in a weird position. No, it's not. You draw it perpendicular, parallel, and like that. This is angle B. So that makes this G cos B, G sine B, and obviously G. And then up here you're going to have U cos alpha and U sine alpha. Okay. Phi x, anybody? Wants to take it on? Killian. U cos alpha, yeah. Plus GT sine. There you go. Plus GT sine B. Because it's being accelerated down the hill. Phi y is business as usual. Cian, what you get for phi y? Yeah. No. Gravity is always acting downwards. So see the direction of G cos B. G cos B is going downwards, but U sine A is going upwards. So they have to be opposing forces or opposing motions. Yeah, exactly. All right, next one, Sx, Ut, cos alpha plus a half Gt squared sine B. And finally, Sy is Ut sine B, sine alpha, minus a half Gt squared cos B. And you're done. Look at question 3 next. In this case here, you're going to put theta in there because it's in an alternate angle to the plane. So oddly enough, you're going to have it's going to be a plus theta. So you can have u cos a plus theta and u sine. Yeah, here. Yeah, they're both the same because they're alternate angles. So that's the main change you're going to use, okay? And it's still downhill. So it's actually pretty much the same answer as the last question, isn't it? Except replace beta with theta and replace alpha with alpha plus theta, and you're done. So it's the same stuff. And is theta y equals u sine a theta minus cost. Oh, sorry, plus. We're going downhill. Gravity triangle again. Oh, good. Now, that's y ut sine. And we're done.